wanted to talk now for a few minutes about a couple of more services that we have, one of which is VPC. And so this diagram that you see in front of you describes how you could connect something like a laboratory or a research facility to the Amazon Web Services Cloud, such that the virtual machines that you provision in the Amazon Cloud are a seamless extension to the customers, to your own internal network. And so typically when you're launching servers on the Amazon Cloud, you would launch servers, you define who can connect to those servers, that they have full network egress to the internet. They're just servers that are running it out there in the cloud. You have very tight security control, not meaning to imply that they're not secure, but they're not part of your network. They're part of another network, and you have to figure out things like potentially opening holes in your university firewall, or having to define open VPN connectivity. With the virtual private cloud, you can provision servers that physically reside in Amazon's data centers, but they become a seamless extension to the network that you see on campus, such that if somebody doesn't actually know that they're running an Amazon Web Services, they wouldn't be able to tell by logging onto the machine. These would look just like any other server that you have access to. I'll skip through the animations here and get on to the next slide. Wanted to talk just a little bit briefly about database options. So I mentioned that we have things like running the ability to install any database you like on EC2. It could be relational databases like Oracle or MySQL or Postgres. You could also install NoSQL databases on EC2, and many of our customers do that, and they distribute across multiple availability zones, or in some cases even asynchronously replicate across regions around the world. If you'd prefer to have us focus on things like patching and installing the database software, taking care of backup and recovery, the relational database service is a great model for that. You're still responsible for creating tables, creating indices, performance tuning the application itself, but we take care of all the physical DBA tasks for you. If you have a NoSQL model that's preferred, we have another option called Amazon DynamoDB, and this one's interesting in that it's all SSD-based database service, key value pair database. And the way that we price this, it's actually priced based on the number of I/O operations per second and storage that you consume, rather than number of hosts or number of CPUs or more traditional licensing metrics that you'll see for database servers. And you can dynamically adjust this. So if you know that on Thursday you're going to run a massive analytics workload against your database, you can dial up the an hour in advance or 15 minutes in advance. You can ask us to dial up the capacity that you can serve out of that database. And for the period of time that workload's running, you'll have access to 100,000 IOPS or 200,000 IOPS or even more. And we'll charge you more for that server for that access while that's running. But then when you're done, you can tell us to dial back down the I/O capacity, and maybe it actually won't cost you anything to run that in the cloud, or it only cost you pennies or dollars per month. So it gives you the ability to very directly correlate your costs to the benefit that you're getting from the infrastructure. We've talked a bit about notifications and queuing. I wanted to talk about Elastic MapReduce, our parallel processing implementation. So very common these days for folks to use Hadoop or Shark or Spark, Hive, as Hive being a SQL interface to Hadoop, Shark and Spark being kind of the equivalents using the Berkeley AmpLab stack that's being developed. These types of systems distribute a workload in an embarrassingly parallel fashion across a large number of commodity machines. There's some friction that's involved in actually installing and configuring and managing the clusters themselves. And so you can either take on that responsibility and build it on EC2, or if you prefer, you can have us manage your Hadoop clusters for you. That's what the Elastic MapReduce service is. I'd like to also mention that all of the services that we offer are available, as I mentioned earlier, through a web console, through command line APIs, but we also have web services APIs, and we also tend to publish developer frameworks or libraries in all of the most common languages, including mobile devices. So one of my favorite applications of the cloud is a researcher at University of Washington who actually created I think it was about a 30-node HPC cluster, submitted a genomics workload against that HPC cluster, but did all of this using his iPhone on his way into the office in the morning. He had an idea for an experiment he wanted to run. So he actually created the cluster, ran the experiment as he was driving into work. Hopefully pulled over before he clicked on his iPhone. And then when he got to his office, the cluster had already been turned off and his results were waiting for him. So this the programmatic access to infrastructure is very, very powerful. If you want to create a stack of infrastructure, in other words, you want to deploy a database server and then maybe running on a Gluster cluster, and you want to build a tier of servers in front of that, and you want to create some DNS records and create load balancers and set up security groups. But you don't want to you don't want to define each of those infrastructure steps every time you want to run this particular application. You can use CloudFormation to create a stack that has either kind of one-click launching of all of that stack with dependencies in place so that you only launch the tier 2 when the tier 1 is online. And it also allows you to then turn off that stack when you're done, so you don't have to go back and physically remove or make API calls for each of the components to that application. But it also has the ability to define parameters so that you can specify, launch it today in our Dublin region or in the West Coast Oregon region instead of Virginia, and launch the tier 2 with 100 servers instead of 50 servers, and specify instance type 1 versus instance type 2. It's a very powerful tool for quickly deploying high-performance computing workloads in the cloud. CloudWatch is our monitoring capability, and if you have a Java application, Elastic Beanstalk is a Java container where you simply deploy your WAR file, and we'll take care of launching all the infrastructure behind that for you. I wanted to talk about data collaboration in the cloud. This is, I think, a really great benefit of deploying solutions in the cloud in a couple of ways. So if you have a project like the Mars Science Laboratory, for example, there's a number of instruments on this rover that'll be landing on Mars in a couple of days. And there are researchers from all over the world that are collaborating on scientific efforts. There are astrobiologists that are going to be developing new techniques for identifying organisms outside of our planet. There are going to be folks that are coming up with new delay-tolerant networking algorithms that will optimize communication between rovers and satellites and Earth-based ground stations. And so having access to machine images that are standardized and data sets that are stored within the cloud makes it very easy for everybody to kind of come together to a place like Amazon Web Services and get easy access to those data sets. Now, one thing that's important, though, is that you want to make sure that you're doing so in a secure fashion. So the image that you see here on the right-hand side is meant to demonstrate our identity and access management capabilities. So this is different from how you would authenticate with an application. We're not proposing to use Amazon Identity and Access Management to determine how you would authenticate with your email applications or anything else that you're running either in the cloud or out of the cloud. This is purely determining groups of users and roles that they can have and what they can do in terms of launching or managing or interacting with Amazon's infrastructure services. So in this case, you have a group of administrators, and Susan is responsible for building machine images that are going to be used to support the developers. Susan's also going to be responsible for defining the security groups that talks about who can connect to the cloud from which locations. If you've got Jim who wants to work from a Starbucks for a week, or from home for a week, is going to send Susan his IP address so she can open up a port for that IP address so Jim can connect and do his work. Kathy and Alan, on the other hand, are testers, and so under these models, Bob and Susan are going to be able to do lots of things. Brad, Jim, Mark, Kevin are all going to be able to develop applications, but they're not going to be able to modify security settings. And the testers are going to be able to view the application and connect to it, but they probably aren't going to be able to register new machine images. These group names are arbitrary. We have very granular control over what permissions you grant to each of the users. And then another way that we enable collaboration is through publishing of public data sets on Amazon Web Services. So anybody can make their S3 buckets public, either readable, even writable if you want. You can define at a very granular level that only these IP addresses can publish or only these AWS accounts can publish to a shared S3 bucket. You can also create snapshots of your elastic blocks for volumes, those virtual hard drives in the cloud, and then share those snapshots with others so that they can easily instantiate copies of a database server or of a file system or something else that might be built on top of those block devices. In addition to that, Amazon actually hosts a number of data sets, including 1,000 genomes data, a number of other data sets around atmospheric data, astrometric data, climate information, geographic information, census data. And we cover the cost of hosting that in the cloud because we feel that those do a couple of things. Selfishly, we suspect that will drive others to bring compute workloads to our cloud so we can monetize that a bit. But largely, we do this because we think that it's going to help researchers get to science faster. If you don't have to source data sets and pull these in from various locations around the world, if they're all just immediately available to you, you're going to be able to focus on your scientific mission instead of having to spend time on the administration of not only provisioning infrastructure, but having to go find all of the component data sets that you might need to be able to